So it looks like what I'm looking at on this image that was sent to me is some basic geometry stuff involving shapes and angles and that kind of thing. So I'm not really going to go through these terms because I think you can look up definitions anywhere. Google can tell you that. But I will help work through some of these different types of problems that we're seeing. So on this page at the bottom down here, where you've got this problem with this triangle and this problem with this angle here and this problem with these angles here, some things that we want to make sure that you're aware of is anytime you're dealing with something with a triangle and the angles of the triangle, and my handwriting on this is not great, so yeah, I have to bear with me on that. Anyway, anytime you're dealing with angles of a triangle, you should know that every triangle that has ever existed, no matter how big or how small, automatically has 180 degrees within the three angles inside of it. So every triangle has three angles. Doesn't matter if it's an isosceles triangle, a right triangle, a scalene triangle. Any triangle has three angles. This one, and this one. And those three angles together add to equal 180 degrees. It's called the angle sum theorem. So when you know two angles, you can find the third one by subtracting the two that you know from the 180. For example, if I told you this angle over here was 40 and this angle over here was 60, I can take that 40 and 60 and subtract them from 180. I really prefer to put them together and say 40 plus 60 is 100. So if I take that 100 out of the 180, I'd be left with 80 degrees left to be this triangle up here, or this angle up here. So when one's with triangles and you're dealing with the angles on the inside, like this one down here, number 8, that's all you're going to do is you're going to take the two angles that you know and subtract them from the 180 because the sum of the angles in a triangle are always 180 degrees. Now, this next one that's next to that number 9 down there, it involves a right angle. And so what we know about right angles, and a right angle looks like this. Typically, you have a little box in it like that. But what we know about that is that that has 90 degrees in it total. So it's possible for me to decide to split this right angle into two angles just by drawing an extra ray through there. And if I do that and split it into two, those two together have to make 90 degrees. So if I told you this one right here was 60, I have to know that this one over here would be 30 because 60 plus 30 makes 90. So the way this question number 9 is set up, though, is that they don't give you the measure of either. They give you an algebraic expression that shows the measure. So anytime you have an expression, something with an x in it like that, the only way to solve for that is to create an equation. And so we have to know what's equal to what, because an equation always shows things that are equal. And so in this scenario down here, we know that this angle and this angle together make the 90-degree angle. So I would make an equation for this one that says 2x plus 17 plus the second angle, 3x plus 8, equals 90 degrees total because the two of them together form the right angle. And then I would solve this equation. And so we do that, of course, by combining like terms. 2x plus 3x is 5x. 17 plus 8 is 25. And then we can subtract the 25 off both sides. Leaves me 65 on this side. Bring down my 5x on this side, and we would divide everything by 5. And so that's going to give me 13. So that tells me that x is equal to 13. Now, the question here is not very detailed in whether they want the value of x or if they want the value of each angle there. But the x value would be 13. If you needed the value of the actual angles themselves, you would substitute that 13 in place of x in both of these expressions and then solve that. So that means, like for this 2x plus 17, you do 2 times 13 plus 17. And you'd calculate that. So 2 times 13 is 26, plus 17 would be 43. Which means this angle is 43 degrees. On the bottom, when we do the same thing, we do 3 times 13 plus 8. So that would be 39 plus 8 be 47. And I can check that because 43 plus 47 together make 90. So I know I'm correct with what I've done there. And then the last one on this page, number 10, says that, or shows this relationship, and I want to show you that. When lines intersect, the angles that are created have a particular relationship. So let me erase this. So the relationship there, anytime lines intersect, you create angles, 4 angles, 1, 2, 3, 4. Angles that are across from each other, so they share this vertex in the middle, but they're opposite each other, like angle 2 and angle 4, or angle 1 and angle 3. Those are called vertical angles, and what we know about vertical angles is that they're always congruent. So if I told you that angle 2 up here was 80 degrees, you would automatically know that angle 4 was 80 degrees. Now, 2 angles that are side by side are called adjacent, but in a set of intersecting lines like this, the 2 side by side angles that are adjacent are also supplementary. That means they add to equal 180 degrees, because 2 angles side by side form one of the straight lines there, and a straight line has 180 degrees in it. So, like here, from angle 4 around to angle 3 forms that full half circle, or that full straight line here. And that's where 180 degrees comes from. So if you knew that angle 4 was 80, you would know that angle 3 was 100, because those two together have to be 180 degrees. So when we look at one like number 10, you're going to do the same thing that we did in number 9, but we're going to have a different relationship here. We look at the information that we're given, and what we know about this angle and this angle is that they're the same because they're vertical from each other. And so the thing that's going to be equal that allows me to create my equation is that 5x minus 4 will be equal to x plus 40. Because those 2 angles are vertical, I can say that they're equal, and I can create that equation. And again, we'll solve that. So we'll move our letters to the left, and we'll move our numbers to the right, and 4 on both sides. 5x minus 1x makes 4x. 40 plus 4 is 44. Divide by 4, and x is 11. Again, I'm not sure if they want the value of x or if they want you to come up with the actual value for the angle there. But if they wanted the value of the angle, you would just plug 11 in for x. So like down here, 11 plus 40 would make 51. And if this one's 51, so is this one, which is true because 5 times 11 is 55 minus 4 would be 51. So I'm not sure what they want there. It's not really clear to me what they want. But if they want the value of the x, you can find it just by creating the equation. If they want the value of the actual angle itself, you have to come back and substitute that into that space. All right, let's go to your second page. Again, here you've got some random definitions. I'm not going to go over the definitions with you. We just did some of what was in number 8 on the last slide, where you had those 2 intersecting lines. And we talked about the relationship between the angles that are formed there, right? So we talked about how 2 and 4 would be the same, and how 1 and 3 would be the same, and how 4 and 3 would be supplementary, or together they'd equal 180, because they form this line here. And that's true about any of these angles that are side by side or adjacent to one another. So in something like number 8, if they tell you that this angle is 110 and they want you to find these other 3, you should automatically know that this one's 110. And you should automatically be able to find these other 2, because you know that 2 that are side by side, like these 2, would equal 180. So if the 2 of them together are 180 and this one is 110, we can do 180 minus 110 and get 70 for both of those. Now, number 9 is kind of similar to that, but you're not looking at 4 angles, you're just looking at 2. But 2 angles side by side on the same line that together create the line. So if I took this whole angle plus this one, together I make the full half circle, which means together I make 180 degrees. So if I know one side of it, so in this example we know that this side is 60, I can find the other side by subtracting that 60 from 180. That tells me this piece is 120. All right, and then this last one, It can get complicated if we're going to go over all the different angle relationships, but none of what you have here goes through all of those. So I'm just going to kind of give you a quick rundown of how angles in a set of parallel lines work. So if you have two parallel lines, and I'm going to draw this, but it's not going to be pretty, so just be ready. Let's see. Try that. Whoop, just kidding. Yeah, we'll go with that. Okay, so we have two parallel lines, like these two. And then they're cut by another line that's not parallel. That's called the transversal, the line that cuts through the parallel lines that is not parallel with them. It's called a transversal. So it usually looks something like this. And so what you end up with is 8 different angles that are formed by these two parallel lines and the transversal that cuts between them. So there's angle 1, 2, 3, 4, 5, 6, 7, 8. Now what you can notice with this, or what you hopefully notice with this, I'll show you this with a shape here. Let's see. We'll cover up part of this, and I'll move that out of the way. So if you look at just one line and the transversal that cuts it, you have a set of intersecting lines that have those 4 angles, just like what we've talked about already. And so what we know about those is that the angles that are opposite each other, the vertical angles, are congruent. So we know that angle 1, for example, is equal to angle 3. And we know that angle 2 is equal to angle 4, automatically because of that. Now, what we also know is if we were to move this, maybe it'll let me. I don't know. Yes, it will. Just kidding. Maybe. I might have made a mistake, y'all. Okay, we can move it like that. So we end up with the same thing at the bottom, too, where I have those 4 angles, and I know that ones that are opposite each other are congruent to one another. But what we also know, because they're parallel, is that this line here and this line here form exactly the same angle with this transversal, because these are at the exact same angle with the transversal as one another. So what that means is that the size that is number 2 here is going to be exactly the same as the size of angle number 6. Those are called corresponding angles, but they have the exact same measure because they're at the same angle with the line and the transversal that cuts between it. So whatever angle 2 is also angle 6. That's not highlighted. And then I can use that to know that angle 8 is going to be the same as angle 6. And then like whatever number 3 is also number 7 because they're corresponding. So 7 and 5 would be the same because, again, they're vertical. So what you really end up with here is 4 congruent angles of one color or one size and 4 congruent angles of another. So whatever the value of 1 is, it's also the value of 3, 5, and 7. Whatever the value of 2 is also the value of 4, 6, and 8. And then what else you know from this is that the 2 that are side by side, like 1 and 2, form this straight line that's here. So because those angles together form this line, those angles together are supplementary. They equal 180 degrees. So basically, any green angle paired with any yellow angle in my picture here together would make 180 degrees. So if you're asked to solve a diagram like this, it's really not difficult to do because you know 4 angles that are congruent to each other. And then if you can solve for an adjacent angle, then you know the other 4 angles too. So when I look at this and see that this angle over here is 15, I automatically know that this one across from it's 15, and that this one that corresponds with it was 15, and that this one across from that's 15. I automatically know all of that. And then if I know this one is 15, I can find the other piece by doing 180 minus 15 and getting 165. So that means this one is 165, and so is this one, and so is this one, and so is this one. So all of those are going to have the same measures. 4 will be one thing and 4 will be the other. You can look at them usually and tell that all the acute angles, the ones that are smaller than the corner of a piece of paper, will be one value, and all the obtuse angles, the ones that are bigger than the corner of a piece of paper, will be another value. And again, I got that second value by subtracting the other one from 180. And then if you look at these last ones, so this one's the same thing. I think you can do that based on what we just did in the last problem, or you should be able to do that one. When you go to work one like this, you're going to have to look at the relationship between the angles that you're given, because you're going to have to find that out and then be able to use that to find the values that are missing. So I would go through and color code these if it were me. So I would say, okay, this obtuse angle here is going to be the same as this one and this one and this one. And I know that because of that vertical relationship that we saw before. And that means I know that this one is the same as this one and this one and this one. So when I look at the information that I'm given, I want to decide, am I given information about two that are the same as each other or two that are supplementary? And that's going to be based on what color I'm looking at with my color coding here. So for this one, I'm given one green and one yellow. And if you remember, oops, I muted myself. I apologize, y'all. If we look back at what we did on the last one, the green and the yellow together made 180 degrees because together they form the straight line. So I'm going to add those two because they're expressions. Remember, to have an expression and find the value, you have to solve an equation. So I'm going to make those two together equal 180 degrees. So I made my equation. Again, if you're given expressions and you're asked to solve, you have to set up an equation. There's no other way around that. So we take this equation and we solve it. So I'm going to combine my like terms. 4x plus x is 5x. 15 plus 5 is 20. Then I'll subtract 20 from both sides because I'm trying to get x alone. So 5x is 160. And then we divide by 5. So x is 32. 15. Yeah, 32. I'm just double checking myself in my brain. Okay, so if I know x is 32, I can use that to find these two angles here by subbing that value in. For this x plus 5, I'll do 32 plus 5 and get 37. For this, 4 times x plus 15, I can do 4 times 32 plus 15 and get 143. Or you can do 180 minus 37 and get 143 that way. Either way is fine. But once you know those two, you automatically know the rest. So I know this green one is 143. I know this green one's 143. I know this green one's 143. And then I know these yellows are 37 each. So suddenly you know all of those. You should be able to do something similar with these down here. This one will be a little bit different. I'll show you 3, and then you'll be able to do 4 based on what we do in 3. So in 3, again, I would color code these before you start. You look at this one is the same as this one, is the same as this one, is the same as this one. And again, it's that vertical relationship we're looking at. And this acute is the same as this one, which is the same as this one, which is the same as this one. So the information that's given to us in this one is about two that are the same color. That means the two angles they tell us about have the same value. So we're not going to add them together to make 180 because that's not their relationship. These up here, you could add them to make 180. Wrong thing. You could add these to make 180 because they were two different colors, and that's the relationship between the ones that are not the same, is together they make 180. But these, because they're the same color, that means they have the same value. So instead of making an equation that equals 180, we're going to make those equal to each other. So we're still having to solve an equation because we're still trying to get x. But what we do is we say 3x plus 4 equals x plus, I'm going to say that's 36. I hope that's what that says. I might be wrong. And then we're going to solve that to get x. So we'll subtract the x to move it to the left side, subtract the 4 to move it to the right side. And we get 3x minus x is 2x, 36 minus 4 is 32, and we divide by 2. So x is equal to 16. And again, we can use that just by subbing that in to the x in one of these expressions. So I'm going to put it here and do 16 plus 36. And that's going to give me 52 degrees. So if this one's 52, every yellow one in my picture is 52. And if I know the yellow ones, I can get the green one by subtracting the 52 from 180. And I get 128. So I automatically know the green. All right, and you should be able to solve the fourth one using what we just did in the last two, deciding which relationship you know and then being able to set that up and solve it. All right, I hope this helped.